All right. Hi, everyone. I'm Shubhie Panicker. I'm giving this talk along with Nicole. She's somewhere still working on last-minute slide updates. But basically, this project is called Web SDK that we've both been involved with. It's sort of Blink's investment in the web framework and tooling ecosystem. And we want to kind of cover the what, why, and how of what we've been up to. So yeah, the core premise of this is that developers, most production apps don't have the capacity to build fully custom infrastructure. So they rely heavily on open source tooling. And so the idea is that if we invested in this tooling and framework space, we actually help more production apps. And in terms of open source tooling, there's tons of different things, but really for the purpose of what I'm talking about, it's this. It's like the framework-based tooling, as opposed to CMSs, et cetera. At a very high level, these are the two broad categories, user UX and DX, that developers and apps are generally struggling with or concerned with. And the focus of our project is primarily on UX, with the idea that others are solving the DX problem. It's not that we don't care about it, but it's that this is the thing that needs more attention. And at a high level, these framework-based apps are struggling with these metrics, right? They're not doing so well on Chrome's targets for what should be first contentful paint, largest contentful paint, first input delay, et cetera. And these numbers are below our targets, basically, especially when it comes up to 75th percentiles and higher. So how should we go about it? And this is the core idea is that there's a big opportunity with tooling to provide good defaults and opinions. And we brainstormed a lot about what to call this thing and ended up with the web framework because it's like the most inoffensive name. But really, it's an end-to-end system that can control the server and client, the build and the serve time environments. And they are positioned to help with DX and UX. And a really good example that we have at Google is Bach Web. This was my past project that I TL'd before joining Chrome. And we have seen a system like this that is opinionated and end-to-end actually help with UX and DX. So it's not just a theoretical idea. So there's a lot of different moving parts when it comes to assembling a system like this. This is just a small set of the concerns that a developer has to deal with. So it's just kind of unreasonable to expect them to reason about all this and string everything together manually. So besides DX, web frameworks also help a lot with performance and UX. And they do that by bringing opinions, like should I see SSR or not? Should I flush my early chunks? Literally how to get the JavaScript CSS data images across to the browser and when. And specifically, we are trying to set up one end-to-end good example by directly investing in Next.js. We're like, okay, this is going to be one canonical example and relying on copying effects and facilitated proliferation across other systems. And again, we're focusing primarily on performance. So we'll talk more about some of these, like why and what, but just a very high level. React is used heavily. Next.js already has a number of opinionated defaults, and we didn't want to build something from scratch. Like I think Google, historically we have a tendency to kind of build our own thing, and then like years down the road we're like, oh no, like our ideas are not being accepted in the larger ecosystem. So this is just a slight different take of like accepting where production apps are today, and informing our ideas directly into them. And we'll talk more about the ripple effects that we are hoping to achieve later in the talk. So at a very high level, we said we're focusing on performance. What is the performance problem? So we did tracing on a bunch of apps, like 25 apps. By far, the biggest problem is the blocked first interaction. And this is typically because it takes some time to go fetch all your stuff across the network. And then it takes a whole bunch of time on the main thread. And this is a really long time for the user to be blocked, waiting, and unable to interact with your app. The second problem is slow FCP, slow LCP, due to a number of factors. This is just a few examples I have. The first byte is slow, takes over a second. We have blocking scripts in head that are render blocking, including like third-party scripts just kind of sneaking in before your FCP, LCP. CSS is really big, so it takes like a second even after you get your style sheet to get any pixels on the screen. And then web fonts are slow, hero images are slow, images are not optimized. It's a long tail of gotchas and problems here. And the third problem is data fetching. Like data is as important as JavaScript in getting these pages rendered and ready for interaction. So I guess like just this sort of cascading problem is pretty common of getting raw data from a REST endpoint and doing a whole bunch of work on your main thread. And then there's all this code that was needed to have loaded in the first place to do all that work. So basically, the way we set out with this project was setting up some success criteria for ourselves for like the last quarter or two. And I just I literally copy pasted this from an internal doc. We wanted to be able to demonstrate that our team can make some incremental improvements in loading perf in this space. We wanted to show that Next.js is actually the right vehicle for this kind of change. In particular, that they are receptive to our changes, and also that they are willing to be opinionated, because that was like a core premise of the web framework in the first place. And finally, we wanted to have prototypes that show that there is significant potential in this space for future improvement in perf. So I'm just going to quickly run through some of the projects. And I'm not going to spend a lot of time on this part of the talk. I just gave a talk at CDS on Tuesday. So if folks that are interested in digging into some of the details, there's a little bit more detail, but also come and meet me later. This is our team that was primarily responsible for all of the changes that I'm going to talk about. And at a high level, it's these 4 things that we focused on so far. It was like, okay, we're going to improve chunking. And in particular, it was, let's just take what Webpack has and, kind of maximize and optimize what it can do. So the core idea here is like, Next.js just had a really simplistic heuristic of having a commons bundle. So you're basically both overfetching on the first route request. It's route level splitting, so you're overfetching on that first request. But every time the user goes somewhere else, you're also double fetching a lot of the resources. So split chunks, like kind of tweaking it so that we solve these problems. And basically, this is what you get, like as you're navigating the app, because we removed all that duplication, you're saving a lot of bytes. So on the left is without, and on the right is with. So at the end, we're basically seeing an order of magnitude less JavaScript being downloaded. And then bundles are smaller and faster navigations, better caching. And in particular, specific bundles are also much smaller, because we saw that those continuous chunks of JavaScript that happen on the main thread, and if you reduce individual bundles and break them down, it's less time on the main thread. The second thing we focused on was differential loading. So just implementing the module or module pattern, like using module as a proxy for a modern browser, having 2 separate bundles, shipping the modern bundle to the modern browsers and a legacy bundle to older browsers, basically. So it's just saving on those polyfills. And overall, this was 7% improvement on the same site. And I'll talk about some of the reasons why this was hard. And basically, in the course of doing differential loading, we found that using the default Babel preset was actually quite suboptimal. So there were actually 2 reasons why we weren't able to get a lot of perf wins out of that. One is the ecosystem problem. You have NPM depth, so you can't actually do differential loading on like the entirety of your app. You can only do it on your own first-party authored code. And the second problem was browsers. Like browser bugs are causing Babel to basically add a lot of extra JavaScript that could be reduced. So this was basically an attempt of like oh, we're not getting enough wins. Let's try to improve the Babel preset. And so this is an experimental preset that we worked on, and it reduced, the compiled output of the code. But it's really just sort of reverse engineering and undoing the cruft that the Babel's adding because of browser differences and quirks. All right, and then the final one was better performance metrics. And basically, like we have a few metrics that show up in the timeline, but we actually needed much more granular metrics that are representative of these apps and actually cover their load performance. So for example, time to hydration is a really critical time until which your app is not even interactable. And similarly, route changes are a second really important metric that wasn't there. So we just went ahead and kind of landed them as user timings and user marks. Okay, so just sort of a quick, moment of like looking back on these changes. The code splitting stuff, there was some low-hanging fruit, but actually it's a massive problem, and I'll talk about what we can do kind of going forward with better progressive fetching and actually granularly fetching and delivering what's needed when it's needed. It's a really hard problem, and there's only so much we could do with just optimizing what was already there. Similarly, for modern JS, this is like a massive problem. And I already said, there was third-party NPM deps is one problem, and then browsers issues and browser quirks and differences is a massive problem. And finally, for perf metrics, we keep, we've been giving talks and writing documentation on this for years, but it's just much more powerful to go and land the changes, make that library available so that it can be consumed in one step by these apps. There's two big projects that are coming in the pipeline, and I'll quickly try to cover those. So we talked about all these gotchas and foot guns with we don't have a good FCP or LCP because of all these different problems. One thing we're trying to take from Google and see if it maps to this open source tooling is this concept of a conformance system. And the idea here is we have basically integrated into all the different compilers in Google 3, like the CSS compiler, the JS compiler, the build system. All of these are integrated with our tooling, and we've sort of reverse engineered all the perf problems down to bad code patterns. And we are asserting that those code patterns cannot be checked in and catching them at pre-submission time. So this is the idea here, to see if, hey, can this concept make sense? So this is really early on. And it's really important that the teams actually have some control over this. It's not, okay, Google is imposing these rules on me. They should be able, as a team, to be like, okay, these are the set of rules I'm buying into as a team. And then there should be a way to opt out old parts of your code bases. Or if you genuinely need an opt-out, have a shared documentation so that your team knows why, it's like a sort of a code between your team. And finally, progressive hydration is a really big problem. And again, I mentioned this issue before. And ultimately, it comes down to there's too much JavaScript, right? We've already, features are expensive. And it's easy to just say, well, reduce it to 100K, but it's not really feasible for real production business critical apps to just shed all the JavaScript beyond the first 100 kilobytes or two and drop all their ads and tag managers and analytics and so forth. And we already tried to bite off a lot of the low-hanging fruit. We've done all these things. We talked about the left stuff was already mostly there, and the stuff on the right is what our team has been contributing. But even after all this is sort of what the initial page loads look like. There's still this long continuous chunk of JavaScript, and during this, the user is unable to interact. And so, there's a lot of work here to do, and some of it is built on top of this idea in React called concurrent mode. The idea is instead of having that single continuous hydration slice, it's chunked up and staggered. So we tried that out in a prototype, and basically it was much better, right? Instead of 600 milliseconds, it's of continuous script. It's a lot less now. It's 53% better. The reason it's not 100% better is what we found was basically a lot of it was the left slice was untouched by what we tried. Only the right slice was affected. So on the left, Webpack is coming in and doing a whole bunch of bookkeeping, and all these modules have to be initialized because they're not deferred. So that means you don't have a fixed initial cost. Your initial cost is arbitrary depending on whatever happened to be on the page. And finally, there's another piece here to actually make this compelling, which is actually prioritizing what the user is interacting with. So in this app, as the user interacts with the carousel or that left bar or specific components or the top header, those parts of the page should be prioritized in terms of getting just that little piece hydrated and ready for interaction over everything else in the app. So there's a lot of complexities with this, which I don't have time to go into. It wasn't a simple I flipped a switch and now all of this happened. We had to do a whole bunch of upgrading the app, upgrading incompatible concepts, getting things ready. So just kind of to summarize and come back to our app. So far, we were able to demonstrate that yes, we made some incremental improvements with the chunking and differential loading and so forth. Did we show that Next.js is the right partner? Kind of, sort of. At the very least, they have been super accepting of our PRs. The collaboration is going really well. We are, having a shared tracker. We have a shared roadmap with them. So that's been super positive. Are they willing to be opinionated? I think the true test is the Conformance system. And so far, they've been super receptive of that change. So for them to be able to embrace that concept and being able to tell their users to buy into that, that would be a really good test of are they willing to be opinionated or not? So far, we think yes. And finally, we said we would have prototypes that demonstrated significant potential perf improvements. I mean, we made a decent amount of progress here. We showed concurrent mode helps. There's a ton of work to actually get that to fruition. Okay, so I'm going to hand off to Nicole at this point. Do you want me to reload? Okay.
Okay, so thank you, Shubhie. That was great. That obviously opens up the question of why invest in the framework and tooling ecosystem. Obviously, we have a limited amount of time and we have to make choices about what we're going to do versus what we're not going to do. So why is this worth our time? MDN did a developer and designer survey, and they got almost 30,000 responses, which is great. I don't think the data is out yet, but it's going to be quite soon. 72% of developers use one of the top 3 frameworks, and that's React, Angular, or Vue. So a lot of things, frequently what comes up when people ask Shubhie and I about why are we doing this for frameworks? What about, the people who aren't using a framework? I think the largest thing is we're finding that that's a very small percentage of developers that don't use frameworks. And in fact, 44% use React alone. So, and the other 2 make up the next chunk of that. And the other 2 are roughly equal. So 12.3% of time spent on Chrome are on pages that use frameworks. And 10.4% of Chrome page loads are on pages that use these frameworks. And this excludes Facebook, so you can imagine that number would be much higher if we did include data for Facebook. We can also look at the top 100 URLs by time spent. And in that case, 30 URLs out of the top 100 are using one of the top 3 frameworks. And if, in fact, React is 25 out of the top 100 URLs. So this is just a big percentage of the web. We also found out that 42% of all developers use Babel. and 53% of all developers use Webpack. So these are the underlying tools. Every chance we get, when we have to pick what layer we're going to modify, we try to push our changes into the lowest possible layer. Because all of the frameworks, for example, rely on Webpack and Babel. And so if we can make a change there rather than in the specific framework we're working on, there's a chance that the other frameworks can have that uptake pretty quickly. So you might think we're advancing the web framework ecosystem, but actually we're just advancing the web. Frameworks are a huge part of the web, and when we make them work better for developers and end users, we make the whole web better. Shubhie alluded to this, but there's a framework is a loaded word. It means like 10,000 things, right? And so on one end of the spectrum, it can mean a UI library or framework, and that would be your Vue, your React, your Angular, that sort of thing. And on the other end of the spectrum is the more of a wrapper framework that provides that end-to-end server client integration. Part of the reason we chose to look at those wrapper frameworks as the primary place that we were going to work is because they control more of the performance puzzle. I think it's been a popular thing to blame performance problems on frameworks, but the reality is a UI framework just can't do that much about it, particularly the ones that don't get heavily invested in what the server and client integration should look like. Typically, that's just not in their wheelhouse. And then you have a few that sort of are in both camps. Angular and Ember try to do both the UI framework, which is updating and creating DOM and application structure, and the web framework, which is that server-client integration. So how does all of this help the web platform? I think the primary thing is that when we make changes to the web platform, they're only meaningful once sites start using them, and once we can get them out on the broader web. And so we started thinking about that as ecosystem activation, and we started thinking of it as a traditional funnel, the sort of funnel that a product team might watch in order to tell if they're getting people through to their checkout process. Because we thought if we take that sort of traditional approach to it, we might actually be able to get good metrics around it. And so Next is the first place that we invest time. Part of why we chose Next is because it's a small enough ecosystem that we believe we'll be able to measure the impact of what we're doing. We'll be able to look at the folks that are on the latest version and see a performance change when they upgrade. So to that end, we have a corresponding goal with that slice of the funnel, and that is that we want to increase use of latest Next.js. As often as possible, we are making it so that our changes are on by default. And as often as we possibly can, we make it so that the developer doesn't need to do anything in particular to get those changes. Like Shubhie was saying, it isn't always possible. There are some changes that require a rethink of your application, and there's going to be stuff in both buckets. But why we track that goal of who's on latest next is because they're going to get things like split chunks and modern JS just by simply upgrading their NPM package. The next layer is the React ecosystem. We chose this because it's huge, right? It looks like around a half of all framework sites are using React, and because we see a lot of copying behavior in the ecosystem already. And I'll get into that in a second. So the goal we want to track here to see if we're getting that ecosystem activation is the percentage of React sites that are using Next, but also those that are using Gatsby, assuming that Gatsby fast follows, and Gatsby's a sort of Next equivalent for static sites. The next layer, the green layer, is the framework ecosystem. And here's where we really get into that copying behavior. So what's great is that the frameworks are all inspired by each other. One tries something and then the others try it. They're all like bringing, sort of developing the state of the art as we're going along. And one thing we had particularly noticed was that the React team announced hooks. I think it was in October of last year. And I think by January, every other framework had said, we've got hooks too, which you might think, oh, that's weird, but it's actually awesome because it means that when they identify something that's really working for their developers, they jump on it. So in order to track the framework ecosystem, it's an explicit non-goal to increase the percentage of folks using React. We think this is a choice that belongs with developers and that they should make that choice according to what's best for their company and their team and whatever other things that they want to play into it. But we do want to track the degree to which that copying behavior is getting those best practices out. And so we'll look at Vue and Angular and the best practices that they're coming up with and the degree to which they're following the ones that we're putting into the Next ecosystem. And then we're also going to look at Nuxt, which is a fork of the Next project, but it works with Vue. And so it has this opportunity to do a lot of the same really important performance improvements. But that said, they are a little bit further behind. So they have a little bit of catching up to do. And then finally, we have the web ecosystem. And the more we go along and the more we look at the data, it seems like the web ecosystem is the framework ecosystem. There's a small slice of bespoke sites that don't use frameworks or don't use the concepts from frameworks. But by and large, when we improve frameworks, we improve developer experience and we improve the UX on the web. Thank you.